back to the second day of the Parent Practicum. I really appreciate the time that you take from your family in order to improve your math skills, and I also hope that you enjoy making new friends here and just get excited about homeschooling. I mean, it's one of the reasons we have these practicums. So, Lisa, I have a question for you.
Okay.
What do you think of when you hear the word math, or what do you think most people think of?
Well, I used to think it's an enigma. Okay.
I see your shoulders.
Yeah, it's an enigma. Now I see math as a mystery to be solved, a puzzle to be put together, and I feel like I have the skills to do that.
But the skills to do that's probably important to the
Very
preface
important,
that.
right? Which is why previously it was an enigma, because it just seemed like something that somewhere somebody could probably figure out, but it wouldn't be me.
So when people are afraid of math or say I don't like math or I'm not a math person, what is it they're really saying?
I don't feel equipped to handle this. I'm afraid that this can beat me. I'm afraid that I don't have the tools that I need or the time, or that I'm not willing to take the time. I'm afraid that I'll never get it. I'll never understand.
And yet all of us pretty much who are watching this video and participating in this conference had at least 12 years of math studies.
Yeah.
What in the world happened? Well, you kind of answered some of that in our previous discussion. But my concern is that we walk into some presuppositions that turn out not to be true about math, and that clouds our just our understanding.
Sure.
So one of the things that people who like math will say, well, let me give you two answers. One, if they really love math, they really do know it, they'll say the same thing Adam would say about Eve. It's beautiful, and that's why I love math.
Yes.
But most people don't even get there.
It's mysterious.
Usually when a young person likes math, they'll often say, because there's like an answer, there's a puzzle that can be solved. It's the same answer for everybody. There's like a comfort in that. But what I like to point out is that's only even true because of the presuppositions you have about math. For example, if I say 2 plus 3, what's that equal?
5.
5. You are presupposing I asked you a question using base 10 or decimal as the digits.
Because that's what I'm familiar with.
Right. As a mathematician or someone who actually understands arithmetic, you would know there's all kinds of math systems out there. There's an infinite number of ways to do math in arithmetic. But no matter how good your program is in math at teaching place value, I've yet to see one that shows students that there's actually this presupposition, this decision that's been made to use 10 digits. The early Babylonians, which all of our, the Hebrews and all of our Old Testament scriptures come from their math system, they used sexagesimal. They had 60 digits, 60. And that number 6 is really important in Old Testament like monies and systems and things like that, because it came out of the Babylonians, but also the whole idea of 666 in Revelations comes from that. So if you don't really understand, like I said, the 3-ness in the last conversation, the 6-ness of numbers, you're missing a whole lot of what could be understood in scriptures. And so there's these presuppositions. So if I said 2 plus 3 but told you it was base 4, the answer is actually 11. Well, when you show that to a young person, and a 5th grader can really understand that. Actually, there's games you can teach students to show them how bases and place value and stuff work when they're younger. But when you say 2 plus 3 is 5, and then 2 plus 3 is 11, and you write that on the board, everyone has this little disharmony. And the students have this question, you know, and you put up there, is one of these true? Is one false? Could both be true? How could both be true? This is math. And yet it turns out they can. And so that's just a small presupposition that has large consequence. That we use just the 10 digits. For those of you, I know Lisa knows this, but if you work in computers, you would use binary, off and on. You would count in base 2. You would have 0 and 1 would be the only digits you used. And so, like I said, if you were sexagesimal, 60. If you work in hexadecimal, which computer programmers do also, base 16. So we walk into plain old arithmetic, not knowing how many options there are, how different the answers can be. And instead of teaching our kids it's black and white, why not just help them see it's a puzzle to solve? And what do you think about what you're doing when you solve this? Now, with my 1st, 2nd, 3rd grader, I'm probably not going to talk to them that way. Right? I just want to know that 4 plus 4 is 8 and get their multiplication tables down. But 5th, 6th, 7th graders, you start putting multiple kinds of answers on the board, they're going to know the numbers actually are interesting.
Exactly.
And so we have lost that idea. Something that I also want to talk about is this whole idea of mathematical laws. For instance, if I say divide a number by 0, so 6 divided by 0, what do you think the answer is? What's the average math book going to tell you the answer is?
That division by 0 is undefined.
Right.
You can't do that.
You can't do that. And if you want to teach your children the inverse operations of multiplication, that's a really good rule. To
Right.
say dividing by 0 is undefined. But what if you're looking at the tangent of a totally vertical line? In other words, what's the slope of a line pointing straight to heaven? Some books will say it's undefinable.
Right.
Some books won't try to answer because they don't know what to say. And other books will say what I believe the answer is, infinity. One thing that's really a concern to me is a lot of our math textbooks right now are presupposing standards that only electronic machines, or I shouldn't say only, the electronic machines have to have as an answer. That human beings, whose brains are far better than a machine,
Right.
don't have to have as an answer. So for instance, if you got an old trig book out from before the 1950s and you had a slope problem divided by 0, it would say the answer was infinity. But now let's plug that into our calculator. What's the calculator show? Math error or undefined. So since a calculator can't divide by 0, we teach in the math books
That it can't be done.
that it can't be done. Instead of saying, in specific situations, you don't want to do it because it causes problems. Right, so a 5th grader learns how to divide. What an interesting thing to show them that you can divide by 0 and get different answers.
Right.
And what if let's have this little quick conversation like I would with some students. So if I said to you, what's 8 divided by 8? What would you answer?
1.
And what if I said you had 8 meters divided by 8 meters?
1 meter.
No. 1.
Right.
Right. Because why? Because meters divided by meters is
1.
1. So when we're doing unit conversions with my students, I'll say, what's a meter divided by meter? And go ahead. 1.
1.
What's,
Right.
so I'll run through all the units and I'll start saying, okay, so what's chair divided by chair?
Right,
1.
exactly.
What's flag divided by flag? 1. So then you get to this place where then that means that 0 divided by 0 is 1.
'Cause
But you just told me I can't do that.
Right.
These are the kind of things that at the arithmetic level can make a math class very interesting.
Exactly.
It's talking about what are your presuppositions. So somebody has said if we're going to use math in the digits we use and the operations we use now, we're going to say you can divide by 0 sometimes and not by 0 other times. And that's the way people would have talked about it. But now that there's computers, it's always if you divide by 0, you can't do it.
That's right.
So our
Math by machine.
Yes, our humanity is being robbed from us. So, so these are the kind of things that, that we weren't taught going through K to 12 math. But people say, well, how do you know this stuff? Because there's no books really that I read for this.
Sure.
It's because I studied arithmetic for 28 years.
You've been playing with numbers the whole time.
Yeah, and then also praying.
Yes.
It's really important when a kid's struggling with something, when you're students or your own children, to pray for ways to make it interesting, to get that, after that period of rest where they've been introduced to it, what is it that they're missing? To add that to the conversation and instigating a question in their head.
That's great. Right.
Then they start thinking, their brain turns on. Okay, so any comments you want to make on that, or?
Well, I think that for a lot of us as parents who maybe struggled with math, as students ourselves, we want something better for our children, which is why most of us are homeschooling. We want something better for our children. But in the arena of math, we tend to fall back on the same methods that were used with us. And so I think that it would help us to seriously look, why are we trying to replicate the same methods that failed us? Many of us did not have an innate love of math and now come to this with the presupposition that math is hard instead of math as a mystery to be unwrapped, to be a present to be unwrapped and a mystery to be solved. And so I think that we have to carefully examine the methods that we are using to teach math to our children, and then it would really help us to learn to do what you did, play with numbers, to think outside the arithmetic box and to ask big questions, and to spend time with math in everyday situations instead of just problem sets. Why do you think at this juncture that Saxon is still a great curriculum?
Well, one of the things about Saxon that I appreciate, and actually I appreciate this about a number of curriculums, is he explains a lot of things that I've just mentioned.
Yes.
How to use the identity law, and neat tricks to using it, what reciprocal numbers really are, what the operations are all about, but they're in the explanation.
I love that about Saxon.
Yeah, but too many of the parents and teach their students to do this. Go to the problem set, do the problems. If they get the problem right, they move
go on.
But if they get it wrong, they might read the problem set. But the thing is, or the explanation, but the explanation is oftentimes what makes the ones that they could do that were fairly easy for them, it explains the deeper magic in there.
Yes,
And
that's
they
right.
use
I'm so glad you said the deeper magic. It makes it sing
Yes.
for me.
Good, yeah. One time I was teaching a Challenge 1 course where we were doing geometry, and after you get beyond the size of a quadrilateral, the interior sum of angles is bigger than the exterior sum of the angles. And so I was showing that to the students, and this girl looked at me and she said, "How can it be bigger on the inside than the outside?" And I remember I was at the board writing, and the spirit just descended, and I turned to her and I said, "Lucy said to her brothers, one day something bigger than the whole universe fit into a stable." And the kids knew exactly what I was referring to, and they started crying. That's what we
That's
want,
cool.
that deeper magic. And you know, if we hadn't all read Narnia and had that as a common conversation, I couldn't have just said that one line.
Right.
So the commonality of math is universal, in spite of our presuppositions being,
Yes.
being different. And that is one of the things that's beautiful about it, is it helps us to communicate across all languages. Everyone worldwide uses the same things, formulas and numbers and things that we use.
It's a unifying principle.
Good. And so that was in a Saxon lesson. I'm telling you, you can teach your kids to love the Lord through Saxon math if you love the Lord just through math in general.
Yes.
And again, it doesn't matter what curriculum you use at that point. It's your love for it.
Right.
Thanks. Thanks for being here.
Thanks for having me.